Hi, welcome to the Euclidean Geometry 101 course. Continuing the chapter about triangles, we will now take a closer look at isosceles triangles and equilateral triangles. We defined an isosceles triangle as one with two equal sides in the previous lesson. We can now state a proposition regarding such triangles. When two sides of a triangle are equal, then the angles opposite to these sides are also equal. Let's prove this direct proposition. We have an isosceles triangle ABC with side AB equal to AC. Let us construct a triangle A'B', C' that is equal to ABC in everything. And after this construction, let's reflect this triangle, this new triangle, and move him until he falls on ABC, starting with the top angles A and A'. Now we know that the angle in A is equal to the angle in A'. So A'C' lines up with AB and A'B' lines up with AC. And because the sides have all the same length, we can conclude that C coincides with B' and C' coincides with B. So, triangle A'B', C' completely coincides with ABC after the reflection, and thus the angle in B is equal to the angle in C'. And since we know that the angle in C' is equal to the angle C, then, according to axiom 1, the angle in B must be equal to the angle in C. We can also state the converse of this proposition. When a triangle has two equal angles, it is an isosceles triangle. We start showing this by constructing a triangle ABC that has two equal angles B and C. We need to prove that AB is equal to AC. We construct again a second triangle A'B', C' that is equal to ABC in everything. Let us again reflect A'B', C' and move it onto ABC. And now we will start by having the base sides BC and C'B' line up. C' coincides with B and B' coincides with C because C'B' is equal to BC. Therefore, C'A' coincides with BA and B'A' coincides with CA because angles B, C, C' and B' are all equal. So, triangle A'B', C' coincides completely with ABC. Therefore, AB is equal to A'C', and since we know that A'C' is equal to AC, then, according to axiom 1, AB must be equal to AC. This proposition has a couple of corollaries. The first corollary states that in an isosceles triangle, the same line segment is median, altitude, angle bisector, perpendicular bisector, and symmedian on the basis. Let's show that this is true. Suppose we have two congruent isosceles triangles ABC and A'B', C', and we have AM and A'M' that are the medians of the respective triangles. Let's reflect A'B', C' and move it onto ABC. A', B', C', and M' will coincide with A, C, B, and M respectively. Firstly, we see that the triangle formed by A', M', C' coincides now with the triangle AMB. So, angle M equals angle Q. But we know that angle Q is also equal to angle N, because the two original triangles were congruent. So angle M is equal to angle N because of axiom 1. Ergo, AM is the angle bisector of A. Secondly, we see that angle AMB is now equal to angle A', M', C'. But we know that angle A', M', C' was equal to angle AMC because the two original triangles were congruent. So that means that angle AMB is equal to angle AMC, and because equal adjacent angles are only possible if they are right angles, we can conclude that AM is also an altitude in the triangle. Thirdly, as AM is a median, it intersects the midpoint of BC. But now we know also that AM is an altitude, and as such, it is perpendicular to BC. So by definition, AM is also a perpendicular bisector of BC. Fourthly, as AM is the median and the angle bisector, reflecting the angle bisector around the median simply means that reflection is the median itself. So AM is also the symmedian. The second corollary concerns equilateral triangles. Because an equilateral triangle has three equal sides, and because of the proposition, it follows that an equilateral triangle has also three equal angles. Also, the converse is true of this. A triangle with three equal angles is an equilateral triangle. We will close this lesson with a remark about congruency in isosceles triangles. We can now see that isosceles triangles that are directly congruent are also inversely congruent, which means that isosceles congruent triangles can not only coincide through translation plus rotation, but also by reflection and a translation plus rotation. This ends the lesson about isosceles triangles. Next time, we will discuss the conditions for having congruency between triangles. If you like this series, consider subscribing to my channel.